Hello students, welcome to my channel Engineers Academy. Kindly subscribe my channel if this helps in your learning. Now we are going to solve this problem which says that locate the centroid x bar of the shaded area. So now we are given this triangular shaded area, and this side of this shaded area is governed by this equation y is a function of x, and this side is covered by this equation also as a function of x. So now we cannot solve this problem by considering the vertical differential strip. Let's say if we consider the vertical differential strip, if you want to find that x bar, since the x bar equation is x tilde times dA divided by the integral of dA. So to evaluate this equation, we need to define our differential area. So if we define our differential area in the vertical direction like this, so we cannot solve this problem, since the height of this vertical differential strip is here it is defined by y, this y only, and when we move this differential strip until here, so then here the height is not defined by only that one y, right? Then we have to write that this height is, this height will be this y value minus this y value. So let's say at this particular instant the y value is, let's say, y1, and at this particular instant the y value is, let's say, y2. So then the height will be y1 minus y2. So if we consider this vertical differential strip, then we cannot integrate this in only one integration. We need to apply two integrations, one integration until x equals to b, and then one integration from x equals to b until x equals to a. So this means that we have to define our differential strip as a horizontal strip, right? So now if we define that this is our differential area, and let's say that one end of this differential area is at a distance of, let's say, x1. This is x1, right? Somewhere here is x1, and the other end is at a distance of x2 from the origin. Let's say that this is x2. So then we can write that differential area, this will be equal to, so this length of this differential strip will be x2 minus x1. So we can say that this is x2 minus x1 into the height. So this height is dy, this is the small change in y. So we have to multiply it with y. So now we need to find this x2 minus x1. So now when x is equal to x2, we can use this equation, right? Since this particular point is defined, we can find this particular y coordinate using this equation, right? Since y is equal to h divided by a x, and at this particular instant when x is equal to x1, we can put that x1 here in this equation. So from this we can write that x1 is equal to a divided by h into y. So this is x1. Similarly, we can define x2 at this particular instant. If the x value is x2, and while using this equation we can find the y value, the x2 value in terms of y. So now we can write that y equals to h divided by a minus b into x minus b. So now if I put x2 here, so then we can write this, we can write that x2 is equal to, we need to cross multiply a minus b divided by h. So a minus b divided by h into y, and here we will be left with x2 minus b. This will be x2 minus b, and if I bring this to the other side, so this will become plus b. So x2 is equal to a minus b divided by h into y plus b. So now we can write x2 minus x1. let me write this dA here. dA equals to x2 minus x1 dy. So now first we need to find x2 minus x1. So let me write that x2 minus x1 is equal to, so this is x2, we can write that x2 is a minus b divided by h into y plus b and minus x1. So x1 is a divided by h into y. So now if we simplify this, this will be equal to a h into y. So a divided by h into y minus b divided by h into y plus b minus a divided by h into y. So this will cancel out and we will be left with minus b divided by hy plus b. So this is x2 minus x1. So now let me write here that x2 minus x1, or we can write it as b minus b by h into y. So let me write that x2 minus x1 is b minus b divided by hy into dy, and if we integrate both sides, so we will be able to find this denominator of this equation. And the integral of dA means that we have to add up all the areas of the differential strips from y equals to 0 until y equals to h, since the differential is with respect to y. So this is from 0 to h. Now if we integrate this, so this will be by and this is minus bh, and this will be y square divided by 2, and this is from 0 to h. So now if I put these limits, so this is bh minus b divided by h, and this will become h square divided by 2, and if we put y equals to 0, so everything will become 0. So now this will be cancelled out, so we will be left with bh divided by 2. Let me write it like this, bh divided by 2. So bh minus bh divided by 2 will give us plus bh divided by 2, which is the total area of the triangle that we already know, half base into h. So this is that blue shaded area. Now the numerator is x tilde times dA. So first of all I will find x tilde times dA. So x tilde is the location of the centroid of this differential strip from the y-axis, is right. So this is x tilde. From here to here, this is x tilde, and x tilde will be equal to this x1 plus the half of the length of this differential strip. So x1 plus, we can say, let me write that x tilde is equal to x1 plus the half of this length. So this is x2 minus x1 divided by 2. So we can write that x2 minus x1 divided by 2. So this is x tilde. So now we can write x tilde. So x tilde is equal to x1 is a divided by h into y from here, and x2 minus x1 is this. So we can write that this will become plus 1 divided by 2 into x2 minus x1, and this is x2 minus x1. So b minus b divided by h into y, or further we can simplify this as a divided by hy, and I will write this term first. So this will become b divided by 2h into y, and it will become minus, this is plus into minus minus, and this is plus b divided by 2. So this is x tilde. Now this numerator is x tilde times dA, so I will write x tilde times dA, and this is x tilde, this is a divided by h into y minus b divided by 2h into y plus b divided by 2 multiplied by dA, and this is the dA, x2 minus x1 times dy. So we will write it as b minus b divided by h into y times dy. So now if I multiply this brackets with this one, so we will have ab, a b divided by h into y. Similarly, if I multiply this, so this is minus ab divided by h square into y. And similarly, if I multiply this, so this is minus b into b is b square divided by 2h into y, and then minus into minus plus b square divided by 2h square y square, and similarly plus into plus b square divided by 2, and plus into minus b square divided by 2h into y, and multiply by dy. This is the y square, right? If I multiply this with the second term, so this is e into b divided by h square into y square. So now we need to add up the combine the y square terms and the y terms. So I will write this is a divided by b h y, this y term. Then this y term, this is minus b square divided by 2h into y, and then this term. So this is minus b square divided by 2h into y. And if we add up both of these terms, so this will be 2b square y divided by 2h. So we will be left with b square y divided by h. Similarly, these two y square terms, so we can write them as minus ab divided by h square plus this is y square, and this is b square divided by 2h square y square, and then we are left with this constant term, this is b square divided by 2 into dy. Now if I take b divided by h and y common from these two terms, so we will be left with a minus b. Similarly, if I take minus b divided by h square common, so we will be left with, and y square also, so we will be left with a and plus b divided by 2, and this is plus b square divided by 2 into dy, and this is a plus b divided by 2. We can further simplify this. I can take an LCM, so this is 2a plus b divided by 2 into y square, so we can write it as 2a plus b divided by 2. So let me write this as 2a plus b divided by 2, and if I take 2 outside, so this will become 2a plus b into y square. So this is equal to x tilde times dA, and now we need to integrate this, and the integration is with respect to y, and the y limits are from 0 to h. So this is from 0 to h. So now when we integrate this, so we will have b divided by h into a minus b, and this will become y square divided by 2. So I will write the 2 here, and then when we integrate this, so this is b divided by 2h square, this will be 2a plus b, and this will become y to the power 3 divided by 3, and 2 into 3 is 6. This is 6h square. This is plus b square divided by 2 into y, and this is from 0 to h. So now if I put these limits, this is b divided by 2h into a minus b, this will become h square minus b divided by 6h square 2a plus b h to the power 3 plus b square divided by 2h. So now this cancels out one h, so b divided by 2 into, this is h. Similarly, this h square cancel out, and now we can further simplify this. This is, if I multiply this, so this will be a b divided by 2h minus b square divided by 2h minus 2ab divided by 6 into h, and minus b square h divided by 6 plus b square divided by 2h. Now further, if we look into all these terms, so this term will cancel out with this term. So we are left with these three terms. So now if I take 6 as an LCM, so this will be left, we will be left with 3ABH minus 2ABH minus B square H, or if we can write that H outside as well. And now 3AB minus 2AB will become AB. So this will be AB minus B square. And now we can take B outside as well, right? So we can further write this as A minus B into BH divided by 6. This is the x tilde times dA integral. Now this is x bar and this is x tilde times dA is equal to this thing. So we can write this as A minus B divided by 6 into BH divided by this BH divided by 2. So now this BH will cancel out, so we will be left with A minus B divided by 6 divided by 1 divided by 2. So we can write this as x bar equals to 2 into A minus B divided by 6, or we can say that this is 1 divided by 3 A minus B. This is that x bar of the centroid of this blue shaded area. So this problem is quite difficult in terms of doing all these simplifications. Otherwise, if you people know the methodology, so then this is the x bar, that is 1 divided by 3 A minus B. So if we are given these lengths, let's say if this A is given as 5 and this is given as 2, so then we can find x bar. This is the universal formula now. So this is 1 divided by 3A minus B. So A is 5 minus, so this is 5 minus 3. 5 minus 2 is 3 and 3 divided by 3 is 1. So this means that x bar will be located at a distance of 1 units from the y-axis. So this is the solution of this quite complicated problem. I hope you people would have understood the method of solving this particular problem. Kindly subscribe my channel if it helps in your learning. Also like this video if you people want me to solve such more problems from Hibbeler statics.